Kusampo, welcome to Bhutan e-learning project. I'm Sangyewang Mu. This lesson is a maths lesson for the Key Stage 4 classes 9 and 10. Today, we are going to learn about matrices. And we are going to discuss about 4 topics, subtopics under matrices. The first one is concept of matrix. Then we are going to discuss about adding and subtracting matrices. Then multiplying a matrix by scalar. And the last one would be multiplying matrices. Let us look into the concept of matrix. Matrix is a rectangular array where the items are being stored and we display information. Did you know that we use matrix in our daily life? We use matrix in graphics software, in electrical circuits, in robotic, and in many more ways. With this, let me give you an example of a matrix. So this is how a matrix would look like. Items inside a matrix, always has to be represented by a square bracket. Then items inside a square bracket, once it is in a matrix, we call it as elements. So here letters A, B, C, D, E, F are all elements. And one thing that you need to keep in your mind is elements, it can be any. It can be in letters, it can be in numbers, and also it can be in shapes. Now the next concept is you have to know the dimension of a matrix. And dimension of a matrix is denoted by the number of rows and by the number of columns. Now let us move on to type of matrix. We have 6 types of matrix. The first one we have is a row matrix. By the name itself, see, row, that means here under this type of matrix, we'll have only one row, but we can have as many columns as we want. So I can give you one example here. And so on. So this is a kind of row matrix where we'll have only one row, but the number of columns, it depends on the user. The second type of matrix is a column matrix. And now when we say column, it's just opposite to the row matrix. Here in column matrix, we'll just have one column, but we'll have many rows. Okay, so this is the difference between row matrix and the column matrix. Now the third type that we have is a square matrix. Now when we say square, you all know that square has the same sides. The 4 sides are all same. Similarly, in a square matrix, the number of rows and number of columns will be same. So this is a simple example of a square matrix. Now if you look into the dimension, we have 3 rows by 3 columns. The fourth type of matrix that we have is a zero matrix, or we also call it as a null matrix. This means that all the elements inside this matrix will be 0. This is a simple example. If you find an element with all zeros, this means that it is a zero matrix or a null matrix. The fifth one that we have is a diagonal matrix. Now when it comes to a diagonal matrix is a square matrix, but what you have to remember here is all the elements will be 0 except the elements in the principal diagonal. Okay, so if you look into this, you'll see that our starting diagonal element is not 0. Then the following So here all other elements are 0 except for the principal diagonal. So this is called as a principal diagonal. And the final one that we have is unit matrix. We call it this as unit matrix, or we can call it as identity matrix. Identity matrix. Here is just opposite to diagonal matrix. What happens here is all the other elements will be 0 except for the principal diagonal will be 1. If you can see the difference between these two, diagonal matrix and unit matrix, it's kind of similar, but they are not similar. They are not same. Why? Because in the diagonal matrix, the elements inside in a diagonal principal it's different, whereas in a unit matrix, all the elements in a principal diagonal is 1. So these are the 6 types of matrices that we have. With this, let us move on to adding and subtracting matrices. To add or to subtract, there is only one common rule that we need to use. There is the dimension of both the matrices has to be same. That is the number of rows and number of columns of both the matrices that you want to add or you want to subtract has to be same. Now let us look into a simple example of adding matrices. How to add matrices now? Now if you look at these two matrices carefully, our matrix A, the dimension is a 2 by 2 matrix, and matrix B, it is also a 2 by 2 matrix. Now why did we have that common rule is because the element in the first row has to be added to the corresponding element in the first row of the second matrix. So that's why the rule is very important here. Now as I told you earlier, the element 0 has to be added to element 4 because they lie in the same position. So here 0 and 4 will be added, 1 and 2 will be added. Similarly, 2 and 0 will be added and 3 will be added to 3. So this is how we add the matrices. So if you look into the rule carefully, the element in the first row of the first column has to be added to the element in the first row and the first column of the second matrix. So this is how we add matrices. Now similarly, we'll look into how to subtract matrices. Now let us take another 2 matrices. So we can take it as a matrix C with the element 4, 5, 7 and 9. Then matrix T with the element 6, 2, 10 and 0. Now let us subtract a matrix C and matrix D. So here C minus D. Alright, now the rule, as I told you earlier, the rule for adding and subtracting are same. We have to follow the same rule here. 4 minus 6, 5 minus 2, 7 minus 10, and 9 minus 0. So here let us see 4 minus 6. Now here comes regarding the sign in between of matrix. That is when we subtract a bigger number from a smaller number, the negative sign, it will always be a negative sign there. So 4 minus 6, it will give you negative 2. 5 minus 3, 7 minus 10, it will be negative 3 and 9 minus 0. So this is how you subtract matrices. Now we are done with adding and subtracting matrices. Here is only one rule that you need to keep in your mind. That is, the matrices that you want to add or subtract, the dimensions has to be same. Now with this, let us move on to the third subtopic that we have, that is multiplying a matrix by a scalar. Now when we say scalar, you already have an idea what is a scalar. It is a single value. We are talking about a single value. So here we are going to multiply a matrix by a single value. Now here you already know we have a 2 by 2 matrix, and you can see a number 2 here. That number 2 is a singular value, is a scalar value. It's a scalar value, or we call it as a single value. Now when we say multiplying a matrix by a scalar, this number 2 has to be multiplied to all the elements inside a matrix. So let us see further. 2 times 3, 2 times 2, 2 times 4, and 2 times 1. Then we have the product. That is, we'll have 6, 4, 8, and 2. So this is a simple concept. This is a simple concept of multiplying a matrix by a scalar. Now, before we move on to the last concept of matrices, that is multiplying matrices, we are going to quickly visit on the topics that we have covered till now. That is, first one we have done with the concept of matrix, and keep in mind matrix is a rectangular array where items can be stored and we display informations. Then the next one is adding and subtracting. For adding and subtracting, there is only one rule that you need to keep in your mind, that is, the two matrices that you want to add or subtract, the dimensions has to be same. And the third one we are done is with multiplying a matrix by a scalar, and here scalar means is a single number or single value. With this, let us move on to the last subtopic, that is multiplying. Okay, multiplying matrices. Now you all know how to add, you know how to subtract, you know how to multiply by scalar. Now we are going to multiply two matrices. To multiply any two matrices, the number of columns in the first matrix has to be equal to number of rows in the second matrix. I'll show that through an example here. So here is a simple rule with which you will be able to understand. That is matrix A with the dimension of m times n, and matrix B with the dimension of n times p. What do you notice here? Both are n, that means they are same. N in the first matrix is a column, and n in the second matrix is a row. Now here, number of columns in the first matrix has to be equal to number of rows in the second matrix. A simple example I can give here with a number 4 times 1, and I know that the inner number here has to be 1 times any number here. Now if you look at this example carefully, you'll see that the inner two numbers are 1 and 1. That means when they are same, this means that two matrices can be multiplied. After this, we'll now look into how to find the dimension of a product matrix. Dimension of a product matrix is, the rule here is, we'll take the number of rows from the first matrix and number of columns from the second matrix. It's just the opposite to the rule that we have for multiplying matrices. When I take the number of rows from here and number of columns from the second matrix, the dimension for A times B matrix would be M times B. So, row from the first matrix and column from the second matrix gives you the dimension of a product matrix. Now here, before we move on to steps to multiply matrices, let me give you a simple activity here. So we have the first pair of matrices here, matrix A and matrix B. Can you all look at these two matrices and check whether these two matrices can be multiplied? Alright, now let us now look into the dimension, because finding out the dimension is very important. So here, if we look into the dimension of matrix A, we have 2 rows followed by 3 columns. Now let us move on to the next one, matrix B. We have 3 rows followed by 2 columns. So what you notice here? The 2 inner numbers are same. This means we can multiply these 2 pair of matrices. Now let us move on to another example where we'll have. Alright, now can you quickly check out whether these 2 matrices can be multiplied? Done. Let us now check it together. The dimension for matrix C, we have 2 by 2. We have 2 by 2 matrix. For matrix D, we have, it's a 3 by 3 matrix. Now, if you look into this, these 2 inner numbers are different. Now, if you look into these 2 examples carefully, from this activity, you will be able to understand that the inner 2 numbers, when they are same, we can multiply the matrices. If they are not same, we can't multiply. With this, let me take you through the steps, now actual steps to how to multiply. Alright, now the first step that you need to keep in your mind when you multiply the matrices is the elements in the first row of the first matrix has to be multiplied to the elements in the first column of the second matrix. And then when you multiply this, look it carefully here. Element A will be multiplied to element E, and then element B will be multiplied to element G, and then we have to add the products. So this is our first step. Now let us move on to the second step. Now in the second step, what we are going to do is we are going to again multiply the elements in the first matrix, but this time we are going to multiply with the elements in the second column of the second matrix. Alright, let us move on to the third step. Now, since we are done multiplying the elements in the first row, we have to now move on to the elements in the second row. Now here, the second elements in the second row also has to multiply to the elements in the first column of the second matrix. C will be multiplied to E, and then D will be multiplied to G. And the fourth step is, again this C and D will be multiplied to elements F and H. C will be multiplied to F, and then D will be multiplied to H. So these are the 4 steps that will help you to multiply matrices. And then one important note that you need to keep in your mind is, always we start with the number of rows will be multiplied by, followed by the elements in the columns. With this, let me take you through an example so that the concept will be more clear. Alright, this time we have a 2 by 2 matrices. So I'll multiply A with B. Now, to multiply these matrices A and B, let us now follow that 4 steps that I have shown you before. The first one, we have to go for the elements in the first row, and then we'll multiply to the elements in the first column of the second matrix. Then we have to multiply it for the second. 6 times 0 plus 2 times 5. Now we are done with the first row. We'll move on to the second. And as I told you here, what is interesting here is to multiply the elements in the second row. The elements of the column will remain same. You just have to change for the element in the row. So it will be 0 times 3 plus 1 times 4. 0 times 0 plus 1 times 5. So we have 3 6s, 18 plus 8, 0 plus 10, 0 plus 4, 0 plus 5. So our sum is 18 plus 6, 18 plus 8 is 26, 10, 4, and 5. So these are the assignments, questions which will help you to understand the concept in a better way. Today's lessons and the topics are made clearer to you. Thank you so much for attending this lesson. I'll see you all in my next lesson.